So the recording has been started. And there you go. That's my screen. And I'm gonna start my packet tracer. And inside of our packet tracer, what we saw yesterday was actually different, I would say, topologies. If I open up one of the topology that we did was this. So this was pretty normal topology that we actually had. And we saw how IP addresses actually can be configured by using DHCP as well. There you go. I have saved the configuration, or I have saved the topology, which actually results in the saving configuration as well. And when I actually try to send traffic from here to here, first time it fails, second time failed. The routing table must or might be exchanged. Yeah, there you go. So it's successful. And then we added up into that topology yesterday, and we created multiple such routers. We had 4 different routers, 4 different switches, and the endpoints were also different over there. Correct? And when we try to send this particular, or when we try to use the configuration like that, then you need to add multiple static routes inside your routing table. Now, if I compare that, there are almost 10 to 15 static route that needs to be added onto the device. So how do you like solve that particular problem from there? So what you do, instead of adding these multiple routes, you make use of something called default static route. Makes sense? So if I have multiple such routes, be it like router 3, router 4, and so, and then there are, let's make up a topology that looks actually like that. So if I place these 2 routers, and if I place some other switches over here, and then if I say the PC is gonna be like this, and then the connections are gonna be connected in this way. This is what the topology was, right? When we actually worked. Okay. So we need to make it over here, because the router that we used was not PT router, so it doesn't have the serial ports. That's why we need to use this one over here. Like this, and then we connect all these devices together. And then the networks that we actually used was 1.0, we had 2.0 here, then we had 3.0, we had 4.0, we had 5.0, then we had 6.0, and we had 7.0, 192.168, of course. This was kind of the scenario that we actually had. Now we saw the number of, I would say, routes that you will need to add over here was about 5 routes, right? And then the number of static route that you needed to add on R4 was again 5 routes. And then there were around 4 routes that needed to be added over here. But let's consider that both of these routers are actually something you can say called the edge routers of your device, and you have different networks that are situated, and you need to reach out to multiple static routes that are going out there. So what I'll do, I'll configure the basic IPs in just 2 minutes, and then we'll look at this scenario how it should be worked. So when I go into R1, I can go into configure terminal, and I can say hostname R1, interface FA0/0, no shutdown, IP address 192.168.1.1 along with the subnet mask, and IP DHCP pool A network 192.168.1.0 along with the subnet mask and the default router of 192.168.1.1. And then you can take an exit and say interface SE2/0, say no shutdown, IP address 192.168.5.1 along with the subnet mask. Correct? Then after that, we went on to R2, and then in R2, we specified the IP config like that, saying no, enable, configure terminal, interface, you can say host name, R2, interface FA0/0, no shutdown, IP address 192.168.2.1 along with the subnet mask, and then IP DHCP pool B, network 192.168.2.0 along with the subnet mask, and then the default hyphen router 192.168.2.1, and then we switch the interface to SE2/0, then we say no shutdown and IP address 192.168.5.2 along with the subnet mask, and then we change the interface to SE3/0, no shutdown and IP address 192.168.6.1 along with the subnet mask. That is exactly what the configuration that we did onto our R2, and you can verify that the interfaces are configured FE0/0, SE2/0, SE3/0. And then we went on to, you can say R3, and we said no here, enable, configure terminal, interface FA0/0, no shutdown, IP address 192.168.3.1 along with the subnet mask, and IP DHCP pool C, network 192.168.3.0 along with the subnet mask, and default hyphen router 3.1, and interface SE2/0, no shutdown, IP address 192.168.3.6.2, interface SE3/0, no shut, IP address 687.1. There you go. Right, and you can verify R3 also is working pretty good. And then lastly, we actually went on R4, and then we said enable conf hostname R4, interface FA0/0, no shutdown, and then IP address 192.168.4.1 along with the subnet mask, and then IP DHCP pool D, network 192.168.4.0 along with the subnet mask, and then we say default hyphen router 192.168.4.1, interface SE2/0, no shutdown, IP address 192.168.7.2 along with the subnet mask, and that is all that we needed to do. So this was how the configuration was actually done yesterday, right? I just gave you a quick review there so that you can relate to that configuration that we did. And now if we see, you see the number of directly connected routes that you have here are around like 2 routes, because if I go on to R1 and if I say do show, or if I say, so here's another thing, okay? When you use, I would say the show commands onto the enable mode, you can directly use them over here. But if you are in global config mode, like configure terminal, and you want to execute like show command over here, so what you need to do, because it's frustrating to go back and forth every time you want to use a show command. So what you can do, you can just say do show IP route. And when you have do show IP route, you can actually also see. So before every show command, you just need to add do if you want to execute that command into global config. So when I say do show IP route, then you can see that these two are the directly connected networks that we have here, right? And then if we look at the other routes, you can see on router 2 and router 3, you have 3 routes connected, 2, 5, and 6. On router 3, we have a node. Yeah, I'll rename that to R3, and we say do show IP route. Yeah, you cannot use the autofill feature. Yeah, that's correct. And then you have this 3, 6, and 7 over here. And then after that, if I say do show IP route here, you have two networks. Now see, when you have number of networks that needs to be added more than like the desired value, then what you can do, man, my screen is shared. I don't know what's happening with you guys, but I'll reshare my screen. And there you go. I have reshared my screen and you should actually start seeing my screen now. Can you see my screen? Perfect. So when we actually talk about something called static default routing. So what we do in static default routing is you don't need to add any specific routes into your routing table. There is just one route that you actually need to add. Okay, and that particular route acts as the default route. And how you add it? You basically add that particular route by saying IP space route 00, because if you check, there is just one route over here. So you say IP space route 0000 space 0000 space, you specify the SE2/0, which is the interface there. Make sense? Now when I hit the enter button over here, then you can check do show IP route, and it says that my static default route has been added over here. Because when you see, it is not just S with the new route that we have added, it is S and a star sign or S and an asterisk. So this indicates that it's a default route. And what does this default route means? That whenever there is going to be any traffic that is coming up to this R1, and if R1 doesn't find the destination information into its routing table, then it's going to consider forwarding the traffic onto the interface that is there with the static default route. Make sense? So if there is anything that comes up to the router and router doesn't know about the destination, then it's going to forward that traffic on SE2/0, because that is what we have told the router by implementing static default route, that if there is any unknown, then forward that traffic to serial 2/0. Make sense? So when I specify that this information over here, and on R2 I can also specify the same over here, IP route 0000 and SE2/0, and take in view over there, do show IP route. There you go. There is also static default route that has been added. Make sense? Now, what about R2 and R3? Because if I say that we have two exit interfaces, right? So if I go ahead and if I say something like on R2 that IP route 0000 and say SE2/0 as well, and then we say SE3/0 as well, because we have two exit interfaces, right? Now, when I check my routing table, what do you see here? There is a static default route that has been added, which has exit interface as SE2/0 as well and SE3/0 as well. So what will happen in this particular case? Any guesses? Can anyone guess what's happened or what will happen here? No, the packets will not be dropped here. What will happen over here is, you see, I will try to send traffic now by getting IP address onto these devices. There you go. And I'll also get the IP address configured onto this PC and these PCs. Get that? Now what's gonna happen here is when I try to send traffic, probably the first traffic is gonna go failed. But yeah, if I resend that traffic, successful. And now if I try to send traffic, failed. And if I again try to send the traffic, successful. You understand what's happening here? If I try to send traffic, failed. If I again try to send traffic, successful. So what's happening is that half of the packet the router is sending on this interface and half of the packet the router is sending on this interface, because it has two exit points, right? So it does something that we call as load balancing. And how does it balance the load? It forwards some of the traffic on the first interface and some of the traffic on the other interface. Do you understand what I'm trying to say here? Yes, it forwards the traffic, like by doing the load balancing between the interfaces that you have. Makes sense? So that's why it is not advised at all to use a static routing when you have multiple exit interfaces on your router. And when you have such scenario that you have multiple exit interfaces, then the only way to implement static routing is implement static routing for the less amount of network that you want to add, and implement static default on the interface where there are more number of networks that are situated. Meaning, if I say SE2/0, then my SE2/0 is just going to reach out to one static route. But if my SE3/0, you can see that this has three indirectly connected networks directing over here. So what I'll do in this case, I will go back and I will remove the static routes that I have added for 2/0. So I'll say no IP route, and then you can see do show IP route. There you go. So you just have one static route over here, and then I will add a manual route for 1.0. And you can check that now. Do show IP route. There you go. There is a static route for 1.0 and a default route facing towards SE3/0. So now if I try to send traffic between here to here, successful, 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 successful. Make sense? Yes, Amar, that's correct. So if you shut down SE3/0, the route will no longer be available into the routing table. And that's why there will just be one route. So that will kind of solve the problem in one way. But then again, when you add this on R2, we will do the same thing. We have more number of networks to be added that faces towards SE2/0. So we'll implement static default on this interface, and we will implement static on the other interface. So we're gonna go onto the router, and then we say IP route 0000 SE2/0, and then we are gonna implement manual routing for the network that is facing towards 3/0 by saying like this. Makes sense what we're talking about? And then like that, I will also, yeah, now my complete network must be converged, and you can see it over here and over here as well. Okay, there is no IP address. Whenever you get this error, it means that there is no IP address that is configured onto the endpoint. So you can go onto this PC and you can say DHCP there, and there you go. And then after that, you can configure DHCP on this as well, and then DHCP there as well, and then DHCP on this as well. And when I do that and try to send traffic from here to here. The first packet fails out, but then successful. Then from here to here, first packet fails out, successful. So that's how you can like make the communication happen there. So on first routing, on first router and last router, we just have a static route and no like static default route and no static route. But on R2 and R3, we have a mixture of static and static default. Do you guys understand what we're talking about and how static routing works now or static default works now? Any questions? Others? Perfect. So go ahead, try doing the modification into yesterday's topology that you did and see if you're good with the configuration that we did. And I'll give you around 10 minutes of time to do this, and then we'll resume with the next thing, which is VLSM, variable length subnet mask. Okay, go ahead, try this thing and let me know when you're done. Thank you. All right. I hope you are done with the lab. So we can move on with the next topic. So do you understand the concept of static routing? We talked about static and default. Default, no? Well, there is nothing much to understand what goes into default because default routing is used in order to. So there's just one logic that you can use this. Whenever you have a router that just has one exit point, then it's better to implement default routing because the traffic doesn't need to be filtered out to different like so that the router can decide on which interface does it actually need to forward that. So if you know already that where to forward that particular traffic and there's just one exit point like this router, so this router doesn't have any choice of forwarding it on some other interface, right? Because it only is connected to one interface there. So that's why we implement default routing. So instead of adding all the other routes, you can just put a route there that says 0000, which will kind of implement the static default routing. All right. Then there is another small concept that you actually need to look into, which is called as floating or floating static route. We have something called floating static route. What is one-time default? I don't know what's one-time default. So we're going to discuss about something called floating default route. Now here's the thing. You might have redundancy that is implemented in your network. For example, if router 1 connects to router 2, not by using just single interface over here, but by using multiple interfaces. So what in that particular case? Yeah, we did this default routing on every router. So over here, I'm designing a scenario where you have one more router in place. And this router actually is connected to both, you can consider it to here as well and to here as well. Okay, which means let's consider something that this particular router has 8.0 and 9.0 network. Okay, now you can see that the type of cable that they have that they're connected with is like this is serial link and this is fast Ethernet link. Because the R3 doesn't have like or R2 doesn't have any more serial interfaces. That's why the router is actually using the fast Ethernet network here. Makes sense. Now when I consider the same, let's configure the IP addresses over here, and I will go on to R1 and configure 8.1 onto the SE3/0 over there. So I'm gonna go on R1 and say enable configure terminal interface SE3/0, no shutdown, IP address 192.168, then 8.1 along with the subnet mask. And then I go into R2 or this new router, which is let's say R5, enable configure terminal, and then go to interface SE2/0. I'm gonna configure hostname as R5, and then I'm gonna say interface SE2/0, say no shutdown, and then IP address 192.168.8.2. And along with that, I'm gonna give the subnet mask, and then I'll also turn on the interface, which is FA0/0, no shutdown, and IP address 192.168.9.1 along with the subnet mask. Okay, and then I'm gonna go on to the FA1/0 on this router, which is R2. Enable configure terminal interface FA1/0, no shutdown, and IP address 192.168.9.2 along with the subnet mask, and take an exit. So you see, by configuring these addresses, what we have done. So we have created a scenario where we can see that there is a redundancy implemented between the connection of R1 and R2, which means that if these two networks or the computers of these two networks want to communicate together, then they can go via directly between R1 and R2, or they can go or they can go directly over there, or they can go with the help of this R5 that has been placed here. Now here's the thing. So if I look at my static routing table, configure terminal, and do show, do show IP route. There is a static default route which says whenever there is any unknown network, then forward the traffic via SE2/0, which means if there is anything apart from that, or like let's say that there is something, the network goes down, the primary link goes down, then what happens? Can anyone tell me? If I go onto the router over here and I say interface SE2/0 and say shutdown, now what? If I check my routing table now, there is no static route that is available. So even though my alternate interface is up and the traffic needs to go by using this via this R5, still there is no route there for that particular network to be sent via the other way. And why is that? Can anyone tell me that? Because the traffic is not declared or the route is not declared. Okay, so here's the thing. So what should I do? Shall I declare a static route or shall I declare a default route? Okay, let's go and say I'll declare a static route, and I will say IP route. Which route should I declare? For 192.168.2.0, right? And then I say 255.255.255.0 and say SE3/0 and take an exit. And then if I say conft and do show IP route, there you go. 2.0 has been added now. Do you think the traffic will go now? If I say from here to here, what do you think? The traffic should travel? No, of course. And why is that? Because we also need to add 9.0. Is it so? Okay. So I'll go on R1 and I'll say IP route 192.168.9.0 space 255.255.255.0 and SE3/0, right? And then after that, I go over here, and on this router we need to add 8.0 as well. So I'll say IP route 192.168.8.0 2550, oops, and say FA1/0, and I will also add a route that goes on to here by saying 1.0. And if I check now, do show IP route, there you go. You have the static route for 1.0 and you have a static route for 8.0. Still, the middle router doesn't know about any of that particular route, because if I check do show IP route here, it says I only know about 8 and I only know about 2 or 8 and 9. So this also needs to know about 1 and 2. So I say IP route 192.168.1.0 255.255.255.0 SE2/0, and then I say IP route 192.168.2.0 255.255.255.0 SE, FA0/0. Correct? And when I say do show or show IP route now, then this router also knows about both the routes now. Now, when I try to send traffic from here to here, then it says failed, try again, successful. Make sense? So you are able to send traffic now between this PC to this PC. And the traffic is actually going via the other route. And if I check that, I can go into the command prompt of the PC and I can try sending tracer 192.168.2.2, and there you go. It's going via these routes. So it's going towards 1.1 first, then it's going towards 8.2, then it's going towards 9.2, and then gets delivered to 2.2. So it specifies that I'm going via this particular route. And if I check it into my routing table, do show IP route, then you can see that's the only route that is available. Do you understand this scenario? Any questions still here? Then we will talk about the further thing. Okay. Then what we are going to do now, I will bring this other interface up. So I'll say interface SE2/0 and I'll say no shutdown. Now the interface is up. Now what's going to happen? Which route will be preferred? Is it going to prefer the SE2/0 route, or is it going to prefer the SE3/0 route? We're talking about 5.0 network will get preferred. Why so? Yes, Soumya, Maksamed, why do you think so? Because it has shortest path? Okay, because it's directly connected there. But 8.0 also is directly connected. Or you say because that's the default route. Let's see. If I look over here and if I can, just a minute, guys, getting an important call. Yeah, sorry about that. So yeah, you guys are saying that the preferred route will be the 5.0, right? Let's check. If I go now and try to send traffic, it's still the same. It is still going through 8.2 network. And if I look into my routing table and say do show IP route here, there you go. Both the routes are there. You have a static route going towards 2.0 and you have a default static that goes towards SE2/0. And even though we have both the routes here, the one that is being preferred is the other one. So you see, if you consider something that says I would say the link that you have over here with the serial one is connected with the shortest distance possible. And the link that is connected the other way via R5 has a longer distance to cover. And even though when we look at over here, then there is something called administrative distance. And when we look at this administrative distance, which is often referred as AD value, then every route over here or every protocol does have some administrative distance value that is written by default. And this administrative distance value, the static has an administrative distance value of 1, and the default route has an administrative distance value of 254. So when a router needs to decide that which route needs to be preferred, then the router will look at the protocol's administrative distance value and it will choose the one that has lesser administrative distance value. Make sense? So it doesn't look at how far is it or how better it is to reach out to the destination, but it will actually consider that particular value to be chosen. And that's why as the longer route is being connected by using static and the shorter route is being connected by using default, this is exactly why it is actually choosing a route that has lesser AD value, and that's why it's going this way. Do you understand it? Sounds good, right? This is how networking becomes fun as we go deeper into it and compare it with the scenario. Yeah, it does not care about the lesser distance. The consideration of lesser distance comes later when there is no competition between the type of protocol that the router needs to choose. Now, this is something you can say the preference or the route preference of static routing. Now, as I was talking about that, we are going to see something that is called as floating static route. This floating static route is something you can say that what if I remove the static default route that is going over here. So what I'll do, if you can look at that in my routing table, 1.0 is learned by static itself. Okay, and over here what I'll do, I'll remove the static route. Do show IP route. And I'll remove this default route. No IP route 0000. And then I say SE2/0. And I will add another static route, IP route 192.168. Now here's the thing. Okay, before removing that particular route, I will add that static route again. Okay. There is some more thing that I need to explain you. If we go deeper into that, SE2/0, take an exit, show IP route. You see the static route is back again. And if we try looking at which route is it going to prefer, there you go. It's still preferring the next route, right? Or it's still preferring a route that actually is connected via the 8.0. Now, over here, we don't, over here, we don't have a static default route that goes out on SE2/0. We just have added the information about 1.0 network on R2 by using static route itself, not default. So when I use this information and look at the command prompt, you see telnet, you see tracert 192.168.1.2. This particular route is using something called, okay, that's a false information. This particular route also is using the other way or the other route to be sent over there. And when you have this particular route over here, you can see that the routing, if you check the routing table over here, then R2 has an understanding that a 1.0 can be reachable via FA1/0 as well and SE2/0 as well. You understand that? But which route is it going to use all the time? It will only use the route that is connected to FA0/0 because that is prioritized. Now what I'm going to do over here is I'm going to remove this particular route. Go into the conf team and I say no IP route 0000 SE2/0. Just a minute. Yeah, so as I have removed this route, what I'm gonna do, I'm gonna add the route again. Say IP route 192.168.2.0 SE2/0, and then I say do show IP route. There you go. Now what do you see? For 2.0, there are two interfaces that I have. One is connected via SE3/0, and the other one is connected via SE2/0. Make sense? Now, when I see that which route is my traffic going to be forwarded accordingly, it is still going by using the other way. It is reaching out to first, it is reaching out over there via 5.2 itself. Okay. However, it's showing you that it's going through 9.2. But what happens is it's reaching out over there on the router, then it's forwarding to some other interface and then some other interface and then to the destination. So internal switching as well works into router. That's none of our concern as of now. But as of now, what you can see is both of them are equal now. There is no default route, so you can say there is just static route, and the router needs to decide which static route does it needs to like use in order to forward the traffic. Should it forward the traffic by using SE2/0 or should it forward the traffic by using SE3/0? And currently, it is forwarding the traffic by using the 2/0, which is the shorter path. Do you understand this? Yes, no? Yes, perfect. Now, when I look over here into the perspective of R2, and when I try to send the traffic, this traffic is also being delivered by using uh, 2.1 and then on this interface and then over here. So both of them, they are basically using the first interface that they know about in their static routing. You see, if I look at the route, it is actually using this particular route, and there is no load balancing that is happening. Okay, so when I say that the one of the interface goes down, the other one will come up, and when the other one will come up, then that is going to be the preferred interface. So it's always the first interface that you have inside the routing table. But this is not how we want it to behave. We want it to behave in a way that when there is the shortest path that is always available, then always use that no matter what. And only use the other path as the backup one. So what we are gonna do, there is something called metric, and metric can actually be set, and the route having lesser metric will be preferred. Okay, so you can also calculate something called metric with the help of a command along while you add the route into your routing table. And how you do that? So what I'm gonna do, as both of these are preferred routes equally, I'm gonna remove this particular route 192.168.2.0 space 255.255.255.0, and if I see do show IP route, there you go, all the routes has been removed. And now if I say IP route, I want to add a route for 2.0 along with subnet mask, and the first interface is SC2/0. With that, I can specify that what should be the distance metric, and I can specify the distance metric between 1 to 255, any value that I want. So I'm gonna say 10 over here for the first route, and for the next route, which is going to be reachable on the same network but with SE3/0, I'm gonna say the metric is 20. And then I'm gonna do the same thing over here as well. That I do have a route that says do show IP route, and I'm gonna remove that route 192.168.1.0. No, metric is different than administrative distance. I'll explain that just a minute. 0 FA1/0. Oh, sorry. Yeah. And then I'm gonna add IP route 192.168.1.0 facing towards SE2/0 with the metric 10 and facing towards FA1/0 with metric 20. Now, as we have added these two routes, what we are saying over here that we are specifying a metric value with the route that we are adding. So with the first route, we specified a metric value of 10, and with the second route, we specified a metric value of 20, and this we followed on both the sides. So when you have such thing in your network, what it's gonna do, whenever you always have the SE2/0 up, then it will always forward the traffic by using the first interface, which has lesser metric value. And then if you consider that if this link goes down, then and then only the backup link will be used. Makes sense? Because if I try sending traffic now, you see the traffic will always go like that. Okay? And if I go over here and check the same, there you go. That's how the metric is actually going. And now if I say, gosh, there you go. Now if I say that my interface SE2/0 goes down and I say shut down. Now what happens? When I try to send traffic now, you see, it's using the other interface in order to forward the traffic. Yeah, the metric can actually be valued, or you can specify the metric by considering that which route do you want to prefer and which route do you want to use as backup. Based on that, you can create a metric value in static routing only, like this. So as you can see, when the first route went off, then and then only the second route is being used. Okay? But if you do not use metric value, and if the primary route comes back again, and there is no metric that has been calculated for that particular route or specified for that route, even then, the router will continue using the current route that it's gonna use, which is the longer distance one. Do you understand what I'm saying? If you do not use metric to specify the priority of the route that you want to use, then the router keeps on using the current route that it's working according to. So redundancy is there, which means that without metric being specified for those routes, when the primary route goes down, then the secondary route it will be up, and it will solve the purpose of forwarding the traffic. But when the primary comes back again or comes back up, even then as well, the router is going to consider using the secondary route continuously over there. Make sense what I'm saying? Exactly. And that's what I'm going to demonstrate, that as of now we have configured a metric with us. And when I try to forward traffic, you see it's going the other way. But now if I go onto the router and say no shutdown, okay, the interface is up now, you can see that. And then if I try sending traffic now, you see it's back to the primary route now. Make sense to you what I'm talking about? This is something that we call as floating static, which means the route actually floats and depends on the metric that which route needs to be used at what time. Interesting concept, right? But yeah, this is how actually static route is used, and these are the variations of static routes that are available. So go ahead, try this scenario and see if it works for you. Okay, there is no modification of commands, there is just something that you add the value, the metric value with yourself, with your route. But try see variations of this, try to create an alternate route and see if you keep one as default and the other one as static, what happens. Then turn both of them to static and then implement floating static route. Make sense? Okay, there is no specific command that we have used, just normal things. So go ahead, try this thing, let me know when you're done. I'll be here. Thank you. All right, let's move on to the next thing then, as you all are good with the config. So the next topic that we want to explore is called as VLSM, which stands for Variable Length Subnet Mask. And in order to do that, let me first explain that to you what this VLSM is gonna mean to us. So, for example, I'll share my other screen with you and talk to you about that. And there you go. I hope you can see my screen now. And the concept that we're going to discuss about is VLSM, which stands for Variable Length Subnet Mask. Right? So you're gonna take, I would say, a scenario where you have four routers. You have this router 1, then you have this router 2, then you have, let's say, this router 3, and you have this router 4. And each of this router has a local area network. So you can say that this router has couple of PCs connected with it with a switch. Then you have this another router which has another set of, I would say, PCs connected over here. And then this R4 also has set of PCs, and this also has set of PCs connected. Make sense? Each of this network is dedicated to some department of your enterprise lab. So you can say that the network number 1 over here is dedicated to sales department. Then the network number 2 is dedicated to marketing department. The network number 3 is dedicated to HR department, and network number 4 is dedicated to admin department. Make sense? And if we look at the number of employees that are going to be connected in this network, are the sales is going to have 120 users. Then marketing is going to have around 60 users. HR is going to have 30 users. And admin staff is going to have around 10 users that are going to be connected. And when you have such scenario, then you can see that the R1 will be connected with R2, R2 will be connected with R3, R3 will be connected with R4, and R4 will be connected again to R1. So this is how the scenario is going to be like. And then you can consider that the only network that you have been given by your network admin is 192.168.1.0/24. You need to segment the network, or you need to create subnetting according to the requirement that we have. So you see, the only thing that you need to notify here is the length of the users in each of this network is different. The first network requires 120 users, the second network requires 60 users, the third network requires 30 users, and the fourth network requires 10 users. So we cannot like go ahead and use 1.0 here, or 2.0 here, 3.0 and 4.0 here like that. It's not possible. So what we need to do is we need to create subnetting according to the range of each network that you go. So the biggest rule, however, in VLSM, do you understand what we're gonna have here? Please respond in chat. Right? We're going to have networks with different number of hosts. Exactly. Now, the only golden rule that you need to follow in VLSM is biggest network comes first over here, which means you create subnetting for 120 at number 1, then you go to the smaller network number 2, then you go to even smaller network, and then you go to even smaller network. Make sense? So this is the biggest rule that you need to follow, or the golden rule that you need to follow, which means that the biggest network or in size will be subnetted first. And the number of network that you come up with doesn't really matter over here. Okay, the number of network that you might have for the first network might be different, then over here it might be different, over here it might be different, and different over here as well. So how we do that? For such scenario, what we are going to do, we are going to specify over here. So what's the requirement of our network number 1? The network number 1 is working in a way that you can say that the number of hosts, or you can say it is for sales, right? So sales department, and the number of hosts that you require is 120. So if I write down my master formula, which is 128, 64, 32, 16, 8, 4, 2, and 1. This is the formula that we use, and then we figure out number of network first, then you go with number of host, then you go with subnet mask, and then you go with ranges, right? So if you figure out number of network, then in VLSM what you need to go ahead, and how you need to go ahead is you first will figure out number of hosts. So as this number of hosts required is 120 for the first network, what you choose is 128 as the nearest value, and which sits at 2 to the power 7. Okay, so what you're gonna do, you are gonna keep 7 bits as off. That's why you will figure out first how many bits needs to be off. That will give you enough number of hosts, and that's 128. And out of, like, as we are using 192.168.1.0/24, what's the, like, how many bits are reserved for host? Only 8 bits, right? Out of that, you need to keep 7 bits, the last 7 bits as off, and only the first bit will be on. That will give you 2 networks. And as you figure out that you're gonna have 1 bit as on, that's why it goes from /24 to /25 for the first network. And the /25 has a subnet mask of 255.255.255.128. That is what the subnet mask is. Yeah, you can see over here, Nikin, that when you have this VLSM scenario here, it means that you need to implement subnetting in a way that the range of, or the length of the network for every network is going to be different here. And that's why when you consider using subnetting, then for this particular scenario, we have 120 users that can be connected with this switch. I've just drawn three lines, but you can have around 120 users that are going to be connected. So for that, we need to use a single subnet, which is /24 by default, which gives you around three, I would say, three network prefixes and one host prefixes. So this one host prefix contains 8 bits, right? And these 8 bits will be the number of host particles. But out of that, we just need to keep 7 bits, because when we see the number of hosts is 120, then from the master formula, the nearest value that comes, or that we can come up with for a network having the host particles is 128. And for that, we are going to keep 7 bits as off, because 128 means 2 to the power 7, if you know. And as you figure out that 128 means 2 to the power 7, this value comes over here into number of hosts. And if you keep 7 bits as off, which means if I draw this like /24 by default into binary. This is how it's gonna look like. Right? This is what the basic thing is. Now, out of these 8 bits, because this is network, this is network, this is network, and this is host for /24. And out of these 8 bits, what we are going to do, we are only going to reserve last 7 bits, okay, as 0 for host. And then this first bit from the last octet will become to 1. So that entirely becomes a /25 network, 888 and 1. So it becomes 192.168.1.0/25 network. That gives you the subnet mask of this. And when you come up with the ranges, then that what all are going to be the ranges that are going to be used, then you can say that the ranges actually will be something. The first network is going to be 192.168.1.0 to 192.168.1.127, and then the next network is going to be 192.168.1.128 to 192.168.1.255. You understand that? This is how we are going to come up with 2 networks, each having 128 as the number of hosts there. Do you understand it? Now, out of these 2 networks, we are only going to use the first network. Okay, so this network will be dedicated to the first one, which is 192.168.1.0 to 192.168.1.127/25. Then the second network that we have, which is this, will be again subnetted to the next requirement. So the next department that we have is marketing. And inside this marketing department, the number of host requirement that you have is 60 users. So we again calculate number of network, number of host, subnet mask, and ranges. And if we come up with a value that is nearest to 60 users, then you have 64 users. You can come up with a network of 64 users, which is 2 to the power 6. Make sense? That's why the number of hosts will be 2 to the power 6, which is 64, which means you will keep last 6 bits. Out of 32 bits, you're gonna keep last 6 bits dedicated for the users, and that's why you will have a network of /26 over here. Make sense? So when you keep up like /26 for a class C network, it means you're gonna have number of network as 2 to the power 2, which is 4 networks. But this doesn't really matter over here in VLSM, because the subnet mask again can be figured out for /26 as 255.255.255.192, like this. And then the ranges are going to continue from where we left. So it's going to be 192.168.1.128 to 192.168.1.191. So that's what the network will be. Make sense? Yes, now. Right. And then the third network that you're gonna have is for HR. And in HR, the number of users are, I guess, 30 users. For that, the nearest value will be 32, which is 2 to the power 5. So number of network, number of hosts, subnet mask, and range is going to be in a way that number of hosts will be 2 to the power 5, which is going to give 32. Number of network for that will become 2 to the power 3, which is going to give 5 networks. The subnet mask is going to be 255.255.255.224, and then the range will be 192.168.1.192 to 192.168.1.223. That's going to be the next network dedicated for that. Make sense? Yeah, the network gets divided and divided, but we only use, I would say, okay, sorry. 2 to the power 3 over here will be 8. Yeah, it is 8. Correct. So we have multiple networks, but we just use the first range that is available, and then we further subnet it. Okay. So I'll write down the networks that we're going to use here. That for 16, we're going to use 192.168.1.128 to 192.168.1.191/26. And then for HR, we use 192.168.1.192 to 192.168.1.223/27. And then over here, if we look at the configuration for the admin, then the admin, which is a network, has a requirement of 10 hosts. And these 10 hosts are going to be some or the other way being used in a way that we will use 2 to the power 4, which is nearest value to it, 16 hosts. So that's why when we say NHSR, it's going to number of hosts will be 2 to the power 4. Number of network again will be 2 to the power 4, which is going to give 16 and 16 each. Then the subnet mask will be 255.255.255.240, and the range is going to be 192.168.1.200. And because 8 cannot satisfy our requirement, we cannot take 8 because the requirement is 10 hosts, right? And then 1.225 to 192 168 1.239. That's what the range will be for the last network, which is of /28. So we're gonna write it down over here, and we specify the fourth network is gonna start at 192.168.1.225 to 192.168.1.239/28. That's how the subnet actually is gonna go. Make sense? We just want 16 users to be configured. The last network ended at 220. Oh, okay. Sorry about that. So we're gonna start up at we're gonna start at 224. Oh, sorry. Yeah, makes sense. That's how the range is gonna be. I hope you understand that. Yes, no? Perfect. So let's go ahead and see how the configuration actually can be done for such type of configuration. So I'll share my other screen with you. You can take a screenshot of this if you want. And this is how our topology is gonna be. So I will stop sharing the screen and I will share my other screen with you. And there you go. You have this topology here. What I'm gonna do is I'm gonna power cycle on all these devices, and I'm just gonna make some modifications. Delete this, delete these links. and over here, right? These are our fast Ethernet networks, and I'm gonna use them in a way that this is our R1, that's our R2, that's our R3, and that's our R4. Okay, so I'll put this across over here like this, and then I'm gonna put it over here like this, right? So the network that we're gonna use here is the number of network doesn't simply needs to be considered over here. You can ignore that. The first network that we're gonna use here is 192.168.1.0/24, which is for sales. Okay. Then we're gonna have marketing department, which is gonna use a network that's 192.168.1.28/26. Okay, this is gonna be /25, right? Yeah, 25. And then you're gonna have 192.168.1.192/27, and then you're gonna have the last one as 192.168.1.224/28. That's how the config needs to be done. So I'm gonna go on each router and I'm gonna configure these networks and the FA0/0, oh sorry, and the DHCP config for them. So I go onto the router first, yeah, and say no, enable configure terminal, then interface FA0/0, say no shutdown, IP address 192.168.1.1, but with the subnet mask of /25. And then I say IP DHCP pool sales and say network as 192.168.1.0, the network ID and the same subnet mask. And the default hyphen router, of course, is going to be 192.168.1.1 itself. Do you understand this config? Pretty simple. We need to use the network. We need to use the valid host IP address, the first IP, and the subnet mask of /25 here. Okay. After doing this configuration, what we're gonna do? We're going to move on to the next one. So I'll open up the R2. However, I need to rename R1 as well. So I'll say host name as R1. Yeah. Then I'll go to R2 and say no, enable conf t host name R2, and then say interface FA0/0. You can see that the R2 needs to be configured with this IP. So I say IP address 192.168.1.129 along with the subnet mask of 192, and then say IP DHCP pool B and say network 192.168.1.128 along with the subnet mask. Oh, sorry, yeah, 192. And then say default hyphen router. Okay, I'll give no shutdown as well. Interface FA0/0, no shutdown. And then IP DHCP pool B. Oh, this shouldn't have been DHCP pool B. I say no IP DHCP pool B. I'll delete that pool and say IP DHCP pool again for marketing. And then say network 192.168.1.128 along with the subnet mask of 192. And then default hyphen router 192.168.1.129. Sounds good? Any questions? And then like that, you can have go to the third router, and this third router actually can be configured in a way. Enable conf t host name R3 interface FA0/0 no shutdown IP address 192.168. Yeah, IP address 192.168.1.193. Yeah, 255.255.255.224. And then say IP DSCP pool HR network 192.168.1.192 along with the subnet mask and default hyphen router as 192, oh sorry, and default hyphen router as 192.168.1.193 there. And take an exit. There you go. And just like that, you go on to the next router, which is this, and configure the address that says no enable configure terminal. Okay, and then interface FA0/0 no shutdown IP address 192.168.1.225 along with the subnet mask of 240, and then IP DSCP pool admin say network 192.168.1.225 along, oh sorry, 224 as it's a network ID along with the subnet mask of 240 and default hyphen router 192.168.1.225 and take an exit and say host name is R4. There you go. All fast Ethernet configurations are done. Let's go on each PC and get the IP there. The router or the PCs might have previous IP addresses, but that's fine. Then go over here. They already have got the IP addresses because the PCs were upright. Let's check if we have the IP. There you go. From the second subnet, they have received the IP. From the, yeah, all good. Then we say on this, perfect. And then perfect. And over here as well. Yeah, that's perfect and perfect. You see, this is how the configuration actually works here. And that's how VLSN can be done. Okay, go ahead, try this fast Ethernet thing first and see if it works for you. And then I'll show you or give you a hint for for the serial configuration and the routing, and then that will kind of be acting as the assignment. But yeah, go ahead, try this configuration over here and see if it works for you. Let me know when you're done. Thank you. All right, as most of you guys are done, am I audible to you all? Please reply. Perfect. So as you are done configuring, I would say the fast Ethernet interfaces of all the routers that we have for the branches, and then you can see it's time to actually get to know about how we are going to make them communicate with each other. Okay, because if you, let's say, these people want to communicate with these, by default they won't, because they both are into different subnets. But in order to make them communicate, we also need to connect both of, like, all of these routers together in this fashion. And when you do connect them, as we have been using in the previous topologies, we used to like specify networks like, for example, 5.0 over here, 6.0, 7.0, and 8.0. And then we would say 5.1 here, 5.2 here, 6.1 here, 6.2 here, 7.1 here, 7.2 here, 8.1 here, 8.2 here, right? This is how we have been behaving with the point-to-point connectivity over there. Do you understand that? But over here, we are not, I would say, going to implement it the same way. Because what we need to do, we need to dedicate, or we need to configure these networks with the help of VLSM, variable length subnet mask. And in the variable length subnet mask, you can say that the number of IPM. So how many networks do we have over here for like doing the configuration between the point to point? Can I say this is one network, this is another, that's another, and that's another? So you have 4 point-to-point networks that needs to be connected. Now, what is the requirement of point-to-point network? There is something called point-to-point subnet that we call it according to. And when we say point to point subnet, it means that the number of hosts that you want are going to be 4 now. Okay. And we say point to point subnet to something called /30. Yes, correct, Prince. So in /30, we get 4 IP addresses, because we have number of hosts as 2 bits will be off there. That will give you 4 IP addresses. One of which will be the network ID, and the other one would be broadcast ID. So what you're gonna do, as you are left with 16 IP addresses, right? Because we only have used till 239. So 240 to 255, these IP addresses are still vacant. And what we are gonna do, we're gonna come up with /30 networks over there, in which you're gonna get number of network, number of host, subnet, and mask and range, in a way that number of hosts will be 2 to the power 2. That's gonna be 4 IP. 2 to the power 6, that's going to be 64 networks. Subnet mask is going to be 255.255.255.252, right? And the ranges will start from 192.1.240 to 192.168.1.243. This is going to be your first network out of that. And how many networks do you need as such? You need 4 networks, like 1, 2, 3, and 4. You need 4 different networks like that. So what you're gonna say, you're gonna create 4 different networks like that. The first one is 240 to 243. The second one is going to be 1.244 to 192.168.1.247. Then 192.168.1.248 to 192.168.1.250, I would say 1. And then the last network over there will be 192.168.1.252 to 192.168.1.255. This is how you will use 4 IP addresses per network, and you will dedicate networks like you will dedicate network like, okay, I'll remove this mark here and over here. Yeah. So for the first network, between the connectivity between router 1 and router 2, you will use 2, or I would say 1.0 or 1.240/30. For the second network, you will use 1.244/30. You will use 1.248/30 and 1.252/30. Do you understand that? So the first IP address of every network is network ID. The last one will be broadcast ID. So you'll use the between, like the two IP addresses between of each network. 241, 242, 245, 246, 249, 250, 253, 254. And then you will assign those IP addresses to the serial interfaces, and that's how your IP configuration will be completed entirely. And once you're good with the configuration, then I want you guys to implement static routing over there and see if the static routing works and make everyone communicate with each other. Do you understand that? Okay. So to make this particular network work, this is going to be your assignment. Okay. And I expect you guys to complete this assignment in this, I would say, week. And then in the next week, we're going to start dynamic routing. Okay, so we'll say RIP, IGRP, OSPF, and that's going to be our motive for the next class. Sounds good? I hope, yeah, you should now, yep, you need to figure that out. I'm not going to help you with the number of things that you have over here and so, but yeah, you guys can use Telegram for the communication over there. Okay. Well, you can reach out to me on the Telegram group itself. We have created a Telegram group, and I every day I look at it, and then if there is anything that needs to be responded there, I do respond over there. So you guys have my Telegram handle. You can reach out to me if you want anything. But then there are other guys as well that helps you if you have any question. So instead of like just me being answering to you, there are other guys as well. And when the doubts are shared commonly, then they help other people as well. So I request you guys to put up your doubts over there. Till then, I hope you enjoyed the class today, in which we talked about static routing, default routing, and floating routes and all, and then we saw how VLSM actually works. Yeah, it's about the static routing. It's about you would say default static, the floating static. We looked about how AD value plays roles, how metric plays roles in selection or influencing the routes, and then we talked about VLSM. That's what we covered today. All right. Thank you so much, everyone. And yeah, do follow me on LinkedIn. Do follow me on Instagram if you're there. And yeah, thank you so much. Take care of yourself. Have a good week ahead. I'll see you guys next week, same time. Take care of yourself. Bye bye. You'll get the recording soon there. Thank you.